For more than 100 years, humanity has lived under a cosmic decree, a commandment written into the very foundation of physics. Nothing with mass can move faster than light. It wasn't just a scientific conclusion, it was treated like divine law. A hard ceiling, an immovable wall, a speed limit not just for travelers but for our dreams themselves. Einstein's equations told us that as you approach the speed of light, the energy required grows exponentially, approaching infinity. And infinity isn't just difficult. It's impossible. So, generation after generation, we accepted the cage. We built rockets, probes, satellites. We dreamed about interstellar journeys, but always under the shadow of the light barrier. Science fiction tried to break it for us. Writers gave us warp drives, hyperspace lanes, wormholes punched through the void. On paper and in film, humanity leapt across the stars in seconds. But whenever reality caught up, physics would step in like a strict teacher shaking its head. No, that's not how the universe works. Until now. Because quietly, behind locked doors, inside anonymous research leaks, and hidden in technical papers with almost no media coverage, something extraordinary is happening. The cosmic code we thought was unbreakable is starting to reveal its loopholes. Over the last decade, physicists and mathematicians across the globe have uncovered not just one, but several mathematically consistent ways to move faster than light. And not just by a small margin. Some models suggest travel 10, even 100 times faster. Suddenly, concepts once dismissed as the daydreams of Star Trek fans are being published in peer-reviewed journals. Equations once laughed at are now under serious investigation. The future isn't just knocking at our door, it's folding space itself around our doorstep. And if this technology becomes real, everything we know about time, distance, and even reality itself changes. This may not just be the next leap for humanity. It may be the leap that redefines what it even means to be human. The loophole, the cosmic speed limit, 299,792 kilometers per second, has haunted us since 1905. A number etched into every physics textbook, taught like scripture. Try to accelerate a ship near that speed and your mass increases, time slows, and the energy required spirals out of control. To actually reach light speed? Infinite energy. A cruel, perfect impossibility. But here's the secret the textbooks often leave in the footnotes. Einstein's equations apply to objects moving through space. They don't forbid us from moving space itself. Imagine standing still on a road, but the pavement beneath your feet begins to move. You don't walk. The road carries you. That's the loophole, the cheat code written into the fabric of spacetime itself. Instead of brute forcing through the light barrier, what if we could warp the stage on which the drama plays out? What if we could bend spacetime around us, creating a bubble that slides forward without the ship ever moving inside it? That's not just imagination anymore. That's warp physics. The Alcubierre drive in 1994, a young Mexican physicist named Miguel Alcubierre proposed something shocking. Using Einstein's own equations, he theorized a mechanism where a bubble of spacetime could be compressed in front of a ship and expanded behind it. Inside the bubble, the ship doesn't move. It just floats in a calm pocket of reality. But from the outside, that bubble surfs through spacetime itself, appearing to exceed light speed. It was elegant. It was beautiful. And it was impossible. At least at first glance. The equations demanded absurd amounts of exotic matter with negative energy densities, stuff no one had ever seen. It would take energy greater than the mass of the visible universe to push a small ship. A tantalizing dream. But still, just a dream. Until one day, decades later, Harold "Sonny" White, a physicist at NASA, began experimenting with something called the Casimir effect, quantum fluctuations between closely spaced plates. What he found stunned him. Microscopic distortions appeared in the data. Natural warp-like bubbles, forming spontaneously at the nanoscale. For the first time, warp wasn't just math. It was something we could touch. And White's refinements slashed the energy requirements. No longer the energy of galaxies. Now, only hundreds of kilograms of exotic material. Still out of reach, but no longer a fantasy. A door cracked open. The gravitational fingerprint. Then came another breakthrough. In 2024, a research team at the University of Potsdam in Germany ran gravitational wave simulations. Their goal was simple. If a warp bubble ever existed, what would its signature look like in gravitational data? The results were breathtaking. Not only could they simulate the expected fingerprint of a warp bubble, but similar patterns might already exist in archived data from LIGO, the Massive Gravitational Wave Observatory. Think about that. It means warp fields may not just be theoretical or human-made. They might already be out there. Perhaps natural. Perhaps artificial. Perhaps traces of technology older and greater than anything humanity has ever built. And here's the eerie part. By studying those fingerprints, we might learn to reverse engineer warp bubbles without ever building one ourselves. Just as ancient humans studied animal tracks to learn how to hunt, we may soon study the gravitational tracks of alien warp drives to learn how to fall. For decades, warp drives were whispered about like fairy tales, beautiful, inspiring, but impossible. Today, at least 3 independent models exist with real math behind them. Alcubierre's original bubble. The Notario drive, a variation requiring less exotic energy. And White's more energy-efficient bubble geometries. None of them break Einstein's rules. None of them violate physics. They simply step around the light speed barrier instead of smashing into it. And they are being studied, quietly, but seriously, in advanced propulsion labs today. And make no mistake, this isn't about indulging sci-fi fantasies anymore. It's about survival. Earth is fragile. One asteroid, one war, one ecological collapse, and we're done. If we want to endure as a species, if we want to secure a future beyond this pale blue dot, faster than light travel isn't a luxury. It's inevitable. Proxima Centauri b, TRAPPIST-1e. Nearby worlds where oceans might already lap against alien shores. They're close by cosmic standards, yet unreachable by current propulsion. Unless we learn to bend spacetime itself. Unless we learn to ride the warp. The time paradox. But there's a catch. If you go faster than light, what happens to time? In Einstein's relativity, approaching light speed stretches time, warps distances, increases mass. Push further, and causality itself begins to unravel. Effects before causes. Flashlights shining before the switch is flipped. Paradoxes stacked like dominoes. But warp bubbles offer a clever escape. Because inside the bubble, the ship doesn't move. Time flows normally. No relativistic time dilation. No paradox. The bubble simply collapses the distance by folding space like paper. Two far-off points touch, and the journey becomes a ripple in reality. Cause and effect stay intact. At least, that's what the math suggests. But if warp becomes real, we will have to redefine not just speed, but sequence. Once faster than light is possible, the question won't just be where are you going? It will be when. The cosmic code. Here's the most chilling possibility of all. White's lab may not have invented warp bubbles. They may have discovered them. Tiny distortions in quantum fields that already exist in the natural order of the universe. What if warp geometry isn't an invention, but a feature? A fundamental part of reality. A hidden lever built into spacetime itself, waiting for intelligent species to discover. And what if those gravitational fingerprints in LIGO's data aren't natural? What if they are trails? Leftovers. The echoes of civilizations older than ours, streaking across the galaxy not with rockets, but by folding the universe itself. If that's true, then warp isn't just our future. It's our inheritance. The silence. And yet, while papers trickle out, while physicists whisper, one thing is curiously missing. Open commentary from NASA, from SpaceX, from the Department of Defense. Why the silence? Rumors have long swirled about classified propulsion programs, experiments shielded from the public. Harold White's lab is technically under NASA, but operates with unusual independence. Reports are often stripped of deeper commentary. Elon Musk has hinted that Mars colonization will require non-traditional propulsion, and in classified halls, physicists speak of military contracts, private sector funding, and prototypes tested far from public eyes. If a warp prototype exists, or is close, it won't be announced on a live stream. It'll be flown in silence, tested in black projects, kept from the world until the moment it tips the balance of power. Because whoever controls space-time doesn't just win exploration. They control the future. Evolution. The implications go beyond travel. According to the Kardashev scale, humanity isn't even a Type 1 civilization yet. We haven't mastered the energy of our own planet. Type 2 civilizations control their star. Type 3, their galaxy. But a civilization that can reshape spacetime itself? That's something beyond categories. That's no longer playing within the universe. That's rewriting it. If warp is possible, then so is manipulating gravity, generating matter from energy, even reshaping perception itself. Warp propulsion isn't the endgame. It's the opening move of a new physics. A physics where distance becomes meaningless, and the difference between here and there collapses into choice. We wouldn't just be building ships. We'd be building a new humanity. And from there, the stars are no longer distant. They are neighbors. But this isn't just about reaching them. It's about what reaching them makes us. Because the moment we bend spacetime to our will, humanity stops being an earthbound species. We become something else. A civilization of spacetime. A civilization of intent. And the question we face now is no longer if. It's who will do it first? And when we arrive, what will we find waiting for us on the other side? If this story ignited your imagination, don't let it stop here. Do you believe warp travel will happen in our lifetime? Or are we opening doors we were never meant to touch? The universe still has secrets. And maybe, just maybe, one of them is already waiting for us, folded just around the